Well, welcome to Mr. Cooper's YouTube channel. Today we're looking at GCSE Engineering, NEA, Testing and Evaluation, the final section of your NEA, your non-examined assessment, which is worth 10 marks. This is a lovely way to finish, and essentially we're looking at how we can kind of test what we've designed and what we've made, and how we can kind of look for improvements but also justify those improvements. So if we look at that first mark band, I'm just blowing this up on my screen so I can see it a bit easier. You've undertaken detailed and objective testing of all aspects of the design using a variety of testing techniques to compare comprehensive specification. So essentially, for your first thing you've got to do is find your specification. That was your list of 8 to 10 points kind of governing what you've designed and how you've gone about it. An explanation of how quality is maintained through the testing, detailing methods that ensure that work is within tolerance or within the right sizes. How does it fit together correctly? And a lot of that will be you've designed it on the laser cutter, you know, it fits accurately there because the kind of tolerances within the cutting is very, very fine. It's within about 0.1 of a millimeter. You've evaluated it by comprehensively analysing and evaluation of all aspects of the completed design, both systems, operation and manufacture. Well-reasoned suggestions made for how and why possible improvements could be made to the design. And it's important that you're not criticising yourself on this. You're looking at ways forward and how you can improve it. Okay, it's very easy to be really kind of critical, saying I didn't do this, I didn't do that, I didn't have enough time. Please don't criticize the amount of time you've got. You've had an hour, you've had a year to do this. It's important that we're quite realistic on that, that your time planning and your time management may not have been the best, but that's not led to it all. Okay, we've had a lot of time to do it, so let's focus on what we have done, what we've done well, what we would change if we were going to do it again, rather than looking at bad points. Okay, let's be realistic. This is the first thing you've made on your own, probably first major thing. Praise yourself, you know, sing your praises. So how to test if no prototypes, if you've not made something or if it's not kind of fully finished. So it might be done via testing various iterations or changes or developments of models, perhaps through computer aided design and simulated testing. So you can look at what you've designed and, you know, how would it have been made? How would it have performed? Would it work? Okay, you kind of predicting a little bit there, and you can get marks for kind of saying how well you've done it in various bits. Circuits can be simulated. Many 3D modeling applications allow finite element analysis, which can highlight stress concentrations. It's probably a little bit above where we need to be here, but the circuit analysis, you could say, right, on Circuit Wizard, I've designed it and I've gone through the simulation part of it where I've clicked play and I can see that there's electricity going. It then lights up my LEDs, it makes a noise, it does it as I've programmed it. And you can talk about that. But then what could you adapt on that? So maybe if you switch a kid's toy on, I'm just reaching around here. I've got a little car in a box here. So this mechanized car I've got here, if it was to be electric or electronically kind of added to, it could have a button that presses and it kind of plays the theme tune for this car. It makes a revving noise before it then shoots off. Okay, and I could say on my systems diagram that I want that noise to play for 3 seconds, then switch off, a light to come on before the motor's engaged and it goes. Okay, so I'm developing my system as I'm going along. Gearing and levers can be simulated or modeled, so you can do card models of that. Easily manipulated materials, like I say, cardboard, your cereal packets at home, just cut them up. Blame me, tell your parents that I've told you to do it. Remember that fully modeled solutions have always been acceptable in the specification. So we don't need to make it from metal and wood. It could be Lego to show various bits. It could be cardboard, etc. Okay, don't copy any of the examples that we give here, though. Use your own. Use the system and the techniques that we're showing you here, but please don't just straightforward copy them. And there are lots and lots of ways of doing this. Technology Student is a fantastic website to visit to get some ideas for this kind of thing. But if you Google evaluation of products, it will give you lots of ways of doing this. We are looking here at a hardness test. Again, the picture's taken from Technology Student, and it's talking about, right, we've tested some materials here, right, and how are we rating them? So result fair, perspex or acrylic is It's not going to take too much impact. It's going to break quite easily. So you're going to get a surface damage, and you're describing what's happening there, comparing one to another. I'm writing up a summary along with the student doing a photo here of themselves doing the test. A drilling test, again, what happens when you drill it, what's the result of it, what happens in that, and again showing pictures of it happening. Filing test, smooth finishing test, polishing it with a emery cloth, wet and dry paper, a file, electrical conductivity, a weight test, so how heavy are these things compared to each other, how much electricity do they conduct. You don't have to do all of those, but that's quite a nice one to bung a page in of testing if you get time. Product testing, again, we're shown with photographs or a diagram measuring it. So we're looking at the size. You've said in your specification it needs to be less than such and such size, or must be this big. Then you could show sizes, or you using a ruler to measure it and showing that you've met that specification point. We're looking at 3 testers here, so we're talking to our users and giving them feedback, or user feedback as we've got written here. So we're talking to people that could use it. Now you can make that up. You can physically go and see someone. You can ask one of your classmates to do it, get a photo of them using it. Okay, take it seriously though. The exam board don't have a sense of humour. Okay, they're not interested in kind of silly jokes as much as I like them. You're looking purely to fill out the form, fill out the sheet, get your marks, etc. Okay, they're not wanting jokes. And your evaluation against your specification is a key one. So list your specification down the left-hand side. Has it met it? Yes or no? A tick or cross, red or green, and then why is it? How has it met it, or why has it not met it? Okay, go through each of your points and see if you met each one. And it's not a problem if it's not met them. Okay, that's where you can evaluate it and you write, this is what's happened, this is why it hasn't met that point, or this is why it has met that point, and you get marks for both. Okay, so please don't think just because it's not met your specification is a bad thing. Okay, that's just life, and you're evaluating the success of it at the end. Positive points, improvements. Notice there we've not said bad points, issues, problems, that kind of thing. Okay, so we're looking at positives. We're selling ourselves, we're boasting about what we've done, and everything that you've made is fantastic. Okay, all the way through from your designing, all the way through to your CAD work, your circuit wizard work, your circuitry and soldering that up. Absolutely incredible. So please boast about that. Sell yourself, blow your own trumpet if you like. No one else is going to do it for you. We've got photos of our product, so show it in a good point. Okay, don't show the bad points of it. There's always going to be errors or little gaps or little things that we've gone wrong on. Then you can talk about what we could do better, not what did we do wrong, where did we go wrong. Okay, we're looking at our improvements. So although I like my maze game, it could be improved and made even better. Not that there's a problem with it. A selection of woods could be available so that parents could choose the type that they like best. A wood such as mahogany would increase the price, but I think parents would be prepared to pay a higher price for a quality product. Okay, so we're looking at what did we use and what could we make it better with. Okay, selection of handle shapes would allow the user to choose the shape they like best. Game could be supplied with a variety of shapes, making that game more interesting to look at and play. So we're looking at, is it as nice looking as it could be, or could we change it and make it better? Coat of arms could be chosen by the customer to reflect their family name. That's a nice little add-on. Okay, this would personalize the product and lift the price for sale. Okay, so it's quite a nice little add-on. It's a development side. It's not saying I've got something wrong in my design. It's just saying this is what I would improve on. In future, the maze game could be based on a rectangular, circular, or even triangular shape. Random statement, but a nice kind of improvement that could be made. And finally, then, evaluation against each point. Again, we've gone through access FM, etc. It's got kind of key points talking about what you've said in your specification. So it's just copying and pasting that down and then writing a little bit. And the specification might take you an hour, 2 hours, but it's again 10 marks, and it's a lot of marks for something relatively easy, I would say. So if we go back to our first slide, our mark scheme, we're looking for that detailed objective testing. We're looking for that evaluative comments, those thinking what was right with it, how can I make it better, what can I improve on. But we're showing some form of testing to test its success. So look at your specification, how can we then make it better? Okay, and did you meet the specification? If not, why not? Okay, then 10 marks for that. Present it under the title evaluation right at the end of your project. 1-2 slides tops, don't go over that, it doesn't really need it. Fill it up with detail, fill it up with testing, fill it up with evaluative comments. Be positive, don't state your negatives, look at the improvements you could make. Okay, good luck with that one. Quite simple to do, like I say, probably 2 hours worth of work. Get it in at the end of your project. Okay, good luck guys, thank you.